Thanks everyone for being here and joining us on our talk, where we will look at how we're working to meet carbon targets and improve building performance. Now, as we face environmental challenges, particularly in the built environment, working with technologies that can help to save energy and support a sustainable future is super important, particularly now more than ever. And one of the key technologies in this effort, in this challenge, is VRF air conditioning systems. So over the course of this presentation, we'll take a look and see how VRF systems are changing, and then absolutely share some of the exciting developments within our product portfolio. Now, we know the world is getting warmer, and this is because of human activity, making immediate action essential. And here in the UK, Part L of the building regulations, they set the standard for energy efficiency by promoting better insulation and efficient heating and cooling systems, all aiming to reduce operational carbon. Now, one significant contributor to carbon emissions is F-gas, which accounts for around about 3% of the UK's total emissions. And these gases, they have a global warming potential thousands of times that of CO2 and can remain in the atmosphere for hundreds of years. So to address this, the EU F-gas phase down aims to reduce the greenhouse gas emissions by promoting sustainable and lower GWP refrigerants. And this initiative, it drives HVAC manufacturers like ourselves to really innovate and develop new technologies, ensuring regulatory compliance and adapting to changes in refrigerant availability and costs. So I've already just mentioned Part L of the building regs, and this is a key regulation that impacts the specification of air conditioning systems that we put into buildings. In 2022, the regulation was updated, increasing the target emission rate for non-residential buildings by 27% compared to the previous Part L standards. And Part L, it also sets minimum efficiency requirements for building services equipment in both new and existing buildings, including heat pumps and comfort cooling systems. And these regulations, they all ensure that air conditioning systems are more energy efficient and help to reduce the carbon footprint of buildings. So the minimum energy efficiency standards, or MEES, are part of the government's efforts to reduce carbon emissions and improve energy efficiency across the whole built environment. MEES, they require non-residential buildings to have an EPC rating of at least an E before they can be leased, and this applies to both new and ongoing leases. Now, in 2019, the consultation around MEES actually proposed a pathway for all non-domestic privately rented buildings to achieve an EPC rating of C by 2027, and then an EPC rating of B by 2030. So the government, they have confirmed that they will publish their outcomes soon, but if these changes do come in and do take effect, the buildings will need to be even more energy efficient. So last year was a big deal, particularly with the launch of the pilot version of the UK Net Zero Carbon Building Standard. Fantastic piece of work. It is a framework for achieving net zero carbon emissions in buildings, and it sets specific limits, targets, and reporting requirements to align with the UK's climate goals, all aiming to keep global temperature rise to 1.5 degrees. And the standard, it includes mandatory limits on operational energy consumption and upfront embodied carbon. Now, even as a pilot version, it is absolutely ready to use. It provides the necessary technical specs that are needed to align with the standard. And as mentioned, it can be put into projects right away, as it covers quite a large range of project types. Now, with the standard as well, there's been a bunch of developments, particularly the beginning of this calendar year, where the pilot testing program began. And this is where a bunch of projects were put forward towards the testing, and they'll help to refine the elements of the standard when the standard is eventually launched. So pilot testing completed a few weeks ago. So I think the standard is due to launch at the beginning of calendar year 2026. So the F-gas regulations. Now, These were developed by the EU in 2006 to phase down fluorinated gases, especially HFCs. And they were revised in 2014 to achieve that 79% cut in emissions across the EU by 2030. So early last year, the EU F-gas regulations came into force, with the first phase down step kicking in at the beginning of this calendar year, 1st of Jan 2025, with more aggressive reductions tightening progressively until a full HFC phase out by 2050. So here in the UK, we've actually had some very recent movement around the UK F-gas as well. Recently, the consultation was launched, I think, a couple of weeks ago. And effectively, this will give us some indication on how closely we choose to mirror or diverge from the EU F-gas regulations. But sticking with the EU F-gas regulations for a moment, so in addition to the overall phase-down schedule, the updated EU F-gas regulations also introduced a full ban on placing several categories of products containing refrigerants onto the market. So for VRF systems, particularly split air conditioning equipment and heat pumps, the GWP limit for air-to-air systems greater than or equal to 12 kilowatts has been set at 750 from the 1st of Jan 2029, and then it's been set at 150 from the 1st of Jan 2033. And this basically means that in 2029, no new R410A VRF systems will be allowed on the market, thus requiring alternative refrigerants with lower GWPs. So maintenance and servicing bans, they also come into play, and starting in 2026, new refrigerants for maintaining or servicing air conditioning and heat pump equipment must also have a GWP below 2,500, and from 2032, even reclaimed or recycled refrigerant must also be below 2,500. Now, if you think about it, there is kind of a link between the sentiment behind the EU F-gas regulations and the UK Net Zero Carbon Building Standard, for instance. They both aim to phase down the use of high GWP refrigerants, and looking at the UK Net Zero Carbon Building Standard, it actually reinforces this by saying that any refrigerants that are used in any in-scope refrigerant systems must meet a GWP threshold, and that threshold has been set at 677, which then puts R32-based systems as a really strong compliant choice for future-ready installations.
Okay.
When we look at the future of air conditioning, really the same factors that have driven its evolution over time will continue to shape its development. Low carbon buildings, the growth of hydronic solutions, low GWP refrigerants, and the advancement in control and monitoring solutions. But adopting new refrigerants does bring some challenges. Most of the new low GWP refrigerants tend to have a classification as either mildly flammable or flammable, which then makes installation and design something that you need to be a little bit more considerate and a bit more careful around. Which then brings us nicely to the importance of standards. Now, standards, they can be horizontal, providing broad guidelines, or vertical, which are then specific to certain products or industries. And these standards, they are essential for promoting safety and best practice in the sector, ensuring that reliability and consistency. When considering safety risks for HVAC installations, it's really useful to consider BS EN 378, and the standard is split into four separate parts, each providing guidance on how to achieve a safe system. So EN 378 addresses safety throughout the entire life cycle of the refrigerant using system, from design and installation through to commissioning and maintenance. And it involves various building engineering professionals, consultants, installers, commissioning engineers, and each part of the standard, it is directed towards different people or different personnel. So part 2, as an example, this focuses on manufacturers, installers, and maintenance personnel. And this division, it divides the responsibility across different stakeholders to make sure that all relevant risk assessment has been carried out across the life cycle of that equipment in that building. And here as well, with EN 378, a consultation recently closed, and the consultation was looking for feedback on the proposed updates to try and better reflect modern refrigerants and modern technologies. Both horizontal and vertical standards, they address safety, which can be kind of confusing, especially with A2L refrigerant systems. And the decision is becoming increasingly more important due to the updated building regs and the updated Building Safety Act from 2022, which then introduces new safety responsibilities throughout the supply chain. So construction professionals, they can refer to a whole bunch of different guidance from industry associations, regulations, and organizations to determine which recommendations to follow and then how to apply them. However, Part F of the building regulations, BREEAM, new construction, REFCON, the IOR, and a whole bunch of CIBSE design guides and codes all actually refer to the use of BS EN 378 as a source for refrigerant design requirements. Now, we mentioned it right at the start. Because we're facing environmental challenges, particularly within the built environment, it requires us to adopt technologies that save energy and support a sustainable future. And one key technology in this effort is VRF air conditioning systems. So in the following slides, we'll have a look at some of the key features of our VRF solution, its benefits, and how it stands out in the market. And then, of course, we will talk about our new R32 YXM VRF solution. So our VRF system, it has a patent design. It has a two-pipe layout throughout the entire layout. And this is particularly good as it reduces the number of brazing points. And again, it saves on space because it saves on riser space, which is typically packed out with other mechanical equipment. It's available in heat recovery, which again is great, considering that the requirement here, or the majority of the requirement within the UK market, is simultaneous heating and cooling. And then Mitsubishi Electric VRF systems, they are modular and simple to design too. And the flexible piping configurations really help to make installation simple. Plus, they all come with fully integrated control solutions, which makes it easier to manage and monitor the system, particularly as this is a key consideration when upgrading legacy infrastructure. Now, these are just a very quick run through of some of the unique selling points or features, but hopefully they show you why they make Mitsubishi Electric a really smart choice when you're aiming to improve the energy efficiency, comfort, and sustainability. To meet increasingly tough carbon targets and to improve building performance, VRF systems, they need to strike a balance, right, between sustainability and familiarity. So on one hand, they should be eco-friendly and easy to integrate into existing setups, meaning they must be able to work seamlessly with the current infrastructure whilst promoting greener practices. And then at the same time, VRF systems must offer flexibility in design and installation, giving us plenty of options to really tailor solutions to specific needs. These systems, they absolutely need to provide that versatility needed to meet a whole bunch of diverse requirements without compromising on performance or sustainability. Now, we mentioned this already a few times. The EU F-gas regulations will significantly impact the type of refrigerants that we can use in VRF systems. And by 2029, new R410A VRF systems will no longer be allowed on the market due to their high GWPs. However, it is important to note that R410A is still acceptable for use in VRF systems for the time being. But the industry has been moving, and has been moving for some time actually. So R32 has really been adopted in the industry and is now almost seen as the go-to refrigerant within the industry. But it's classified as A2L, mildly flammable. So we need to include safety features like leak detectors, alarms, and safety shutoff valves in any new product development. And talking about new product development, so our new R32 YXM range, it will be available in both our Mini and Maxi systems, or with a complete range of indoor units. So the Mini VRF range, which is the side discharge units, these will start from 12 kilowatts and go all the way up to 34 kilowatts. And then the Maxi range, which are the vertical discharge units, so they will start from 22 kilowatts and go all the way up to 34 kilowatts on the small chassis. And then on the larger chassis, we're able to go up to 56 kilowatts. And if you need capacities greater than that, you'll have to bolt the modules together. That can go all the way up to 113 kilowatts. And the maxi range will be available in both VRF and HVRF. And then the point at the bottom, I think that's important to note that running alongside these options until 2029 will be our existing R32 VRF range. But I realize I've mentioned HVRF, and just before going in and talking about the new R32 YXM, I think it's probably a good time to maybe reflect on this technology. It was a big deal for us when it was launched 10 years ago, and it's still very much part of our existing product portfolio. So HVRF, or hybrid VRF, it delivers simultaneous heating and cooling, but it uses water instead of refrigerant in the occupied space, which is great because it reduces risk to occupants and removes the need for leak detection, saving installation time and costs. Now, at the heart of the HVRF is the hybrid branch controller box, or the HBC. This is connected via traditional refrigerant piping to the outdoor unit, but from the HBC box to the indoor units, you have water piping. And even though it uses this water piping, it's still able to deliver mild air-off temperatures and a really good stability of temperatures all year round. And then additionally, by using R32 refrigerant, we're able to use a refrigerant with a significantly lower GWP, but because the refrigerant is only between the outdoor unit and the HBC box, we have a lower overall system volume. And HVRF2, it's had its fair share of evolution and R&D over the years. So probably the most notable one was the development of the vertical HBC box. Space in projects is something that's always seen as a premium. So to address this, we developed the vertical HBC box with a significantly smaller footprint, so it can fit quite nicely into riser spaces. In terms of projects, VRF, HVRF can be used in a whole range of different projects and applications: retail, education, healthcare, hotels. And if we take Durham University, for an example, they decided to go down the route of R32 HVRF because they wanted to future-proof their building and also try and reduce the embodied carbon. So with HVRF, well, they still get that plug-and-play flexibility that you get with any traditional VRF solutions. And then, as mentioned, the refrigerant's just between the outdoor unit and the HBC box, so significantly lower overall system volume, and they chose to go down the R32, so lower GWP. Plus, the future-proofing element. Because the connection from the HBC box to the indoor unit is just traditional water piping, if a new refrigerant comes along and they need to do an upgrade or any change, that second half of the system from the HBC box to the indoor unit can remain unchanged. And this is just a very quick snapshot of some of our case studies. What I'd recommend is head across to the document library where you can see these case studies and more. You don't just have to hear from Mitsubishi talking about the products. You get to hear the client's story as well. So some of their challenges, their problems, and then how they figured out a solution all the way to the implementation. So with the new R32 YXM solution, really, we're seeing it not just as a simple upgrade. It is, quite frankly, a game changer. And over the next few slides, we'll talk about some of the unique selling points of this solution and see how it can transform your projects to help you achieve your goals. So this time around, the innovation is not focused around R32. This time you'll be getting a completely new chassis design with advanced technology, and this new design is set to significantly enhance our range of VRF systems, providing greater flexibility and performance across various applications. And this advanced technology, it will bring substantial cost savings in terms of running expenses. And the best part, again, it still maintains that familiar plug-and-play capability that VRF systems are known for, ensuring that easy and seamless integration into your projects. And this combination of innovation and practicality really makes this new solution quite exceptional. So here, some of the key features. The new R32 YXM VRF solution, it will be our most flexible solution ever, particularly if we look at location flexibility. The footprint is around about 6% smaller than our current R32 competitors, And that's great considering roof space and plant room space is normally quite crammed with other mechanical equipment. Our new VC box, this will come with up to 12 ports and will have built-in shut-off valves. And the VC boxes, they'll still have that low height of 252 millimeters. So you'll still be able to fit these into really tight ceiling spaces. And then pipe runs. So previously, the pipe run, when you had the outdoor unit above the indoor unit, the vertical pipe run was 90 meters. But seeing that we have so many more high-rise buildings, this has now been extended too. This now goes up to 113 meters. And acoustic performance. This is another key consideration in projects, and our 5-step low noise mode allows you to really easily customize the sound levels. And then for even more control, we offer an 80 Pascal static pressure option, which again is perfect for plant room installations or when any acoustic enclosures are needed. So right off the bat, we have improved the efficiency. And here we have a comparison of the SCER and SCOP of the 30 kilowatt YXM R32 solution versus our existing range. And as you can see here, there's been an approximate 20-ish% improvement in the cooling efficiency and a 30-ish% improvement in the heating efficiency. Again, making a really strong case for using the R32 YXM solution in new projects and upgrading, especially where that performance and sustainability is key.
Sure.
Now, in 2016, when we actually launched the existing chassis, at that time we highlighted our unique aluminium flat tube heat exchanger, which was a big deal, and it really bumped up the seasonal efficiency. Again, this time around, we have an efficiency improvement. So the outdoor unit is equipped with a newly designed heat exchanger that comes with aluminium flat tubes, but the flow of refrigerant from the main distributor is now done vertically. On the new heat exchanger, when the system is in full heating or majority heating, the mixture of liquid and gas is now directed from a horizontal distributor and fills the coil evenly, using every section of the heat exchanger and then improving phase change. And then additionally, more and thinner, closely packed tubes increase the heat exchanger surface area, improving the cooling efficiency through a higher density arrangement. So what does this continued innovation in R32 actually mean in practical terms? Well, compared to our current chassis, the new design delivers around about 20% reduction in running costs and lower operational carbon emissions, which then translates to meaningful and improved sustainability for our customers. And these carbon reductions, they also help to support broader CSR goals, helping organizations to meet environmental targets whilst benefiting from system efficiency and long-term cost effectiveness. So we have reduced system charge, lowering the embodied carbon, and improved seasonal efficiency, reducing operational carbon. And when we consider the overall picture and conduct a whole life carbon analysis over 15 years, our new R32 YXM solution continues to show better performance compared to our market competitors. It is interesting to see here the middle column, which is HVRF. This still comes out on top with the lowest whole life carbon. As our grid is getting cleaner and the weight of operational carbon will be lower over the years. However, thanks to the lower overall system charge, the refrigerant emissions on HVRF will be smaller. So we mentioned that R32 is mildly flammable and it therefore requires careful design. And I've mentioned again, Part F of the building regulations, BREEAM, REFCON, FETA, and a bunch of CIGSE guides all refer to the use of BS-EN 378 for refrigerant design requirements. So how does that actually link into the new R32 YXM? Well, R32 YXM complies with Part 3 of BS-EN 378, and practically it includes a sensor and alarm kit with an independent power supply. So if a leak is detected, the shutoff valve at the BC box closes and the sensor and alarm kit provides an audible and visual alarm. All the remote controllers and the centralized controller will show an error message and the address of that affected indoor unit. The centralized controller will also sound out an alarm, and the affected indoor unit will actually stop operating whilst all the others continue to work. And importantly, our detectors, they have a 30-year lifespan compared to just 10 years for many current R32 competitors. And again, this means fewer replacements, lower operational costs, and I guess greater peace of mind for our clients. So our new R32 YXM, it builds on the VRF system that you already know and trust, but actually takes it to the next level with smarter, more sustainable features. You'll get better comfort, improved safety, and a noticeable drop in carbon emissions. And it's all part of our commitment to pushing innovation forward and doing our bit for the environment. So whether it is a new build or a retrofit, the R32 YXM gives you the tools to deliver reliable performance, lower emissions, and greater control without compromise. But that's not quite it just yet. So at Mitsubishi Electric, we believe that launching a really nice, cool, wonderful product like the R32 YXM doesn't just stop there. We need to make sure that we have the right infrastructure around it. So I mentioned it earlier, the UK Net Zero Carbon Building Standard. It really highlights the importance of carbon-conscious design. So our net zero design team, they will work closely with businesses to understand their challenges and provide tailored solutions that support their sustainability goals. Our engineered solutions team even, they offer expert technical advice to really help you find the best fit system, whilst our after sales team are there to provide rapid support. And then we also invest in knowledge sharing through our training team, offering a whole bunch of professional courses and training to keep customers up to date with the latest technologies. And then lastly, the document library. I mentioned it earlier when talking about the case studies. It's a free resource that you can access this and see a whole bunch of information about the Mitsubishi product range and blogs and thought leadership articles. So definitely a useful piece of information. That's it for me. I hope this gives you a clearer picture of how Mitsubishi Electric can support the delivery of high quality, sustainable heating and cooling solutions.